This is about William D. Phillips on Einstein's relativity. This is a talk by William D. Phillips, and the relevant word is when he gets to Einstein is the word if. If. It's going to take some time before he gets the word if, but it's relevant. And the talk I'm referring to is this one. It's Einstein, Time and Light by William D. Phillips. It's a talk he gives. First I'm going to show you who he is. From there onto this is William Daniel Phillips. He's a Nobel Prize winning American physicist. And there he is. And he's going to give a talk on his work, and it initially starts off involving Einstein, and then he goes off onto playing around with cold, freezing things. So this is the talk, Einstein, Time and Light by William D. Phillips. It's from the opening ceremony of the International Year of Light at the UNESCO building in Paris, France. So let's start now. Yeah.
Speaker this morning is William D. Phillips. He's a fellow of the Joint Quantum Institute, which is a cooperative endeavor of the National Institute of Standards and Technology, or what we call NIST, and the University of Maryland. At NIST, he heads the Laser Cooling and Trapping Group in the Quantum Measurement Division. And at the University of Maryland, he's a distinguished professor of physics. And at the Joint Quantum Institute, he's the co-director of an NSF-funded Physics Frontier Center studying quantum phenomena across a subfield of physics, subfields of physics. Lastly, you should know that in 1997, Dr. Phillips shared the Nobel Prize in physics for the development of method to trap atoms with laser light. And this is going to be a very fun talk, as you can see from the demonstrations here. So I'll introduce Bill Phillips.
So that's where he is. So I jump along now to when he's going to start talking about Einstein. About here. Okay. We pick it up from here. He's going to start going on about Einstein. When you got the subtitles here, it's only a rough. And they are only rough. The person putting the subtitles on is not always accurate.
Time and light. What does Einstein have to do with time? Well, Time put Einstein on the cover of their magazine as the person of the century, and I think we would all agree that it was a good choice. And so many of the things that Einstein is remembered for have to do with light. He came up with the idea of stimulated emission, which is the basis of the laser. General relativity is one of the anniversaries that we celebrate in the International Year of Light. Bose-Einstein condensation makes atoms behave in many ways like lasers in their wave-like property. And of course, the thing that Einstein got the Nobel Prize for was light as particles, the photoelectric effect. But probably the thing Einstein is most known for is his theory of special relativity, which is a 110-year anniversary.
So you even got the number thing wrong there. It's 110-year anniversary, so it can be quite annoying, these subtitles.
This year, and it was all about light. And with it, Einstein changed our very conception of space and time. And he did this by asking himself a question that I suppose people have asked themselves since the beginning of time. What is time? What is this strange thing that constantly seems to be flowing, yet is always in the present and will soon become the past? And what Einstein said was that time is what a clock measures.
So it should be saying time is what a clock measures. So that is pretty silly thing to say, really. If you've got clocks going at different rates, then that's not really what was meant by time before Einstein. But Einstein seems to be wanting to accept clocks going at different rates. Clocks really should be measuring this abstract concept of time, and really they should be, that abstract concept of time is time should be all be going at the same rate. So making this silly thing saying time is what clock measures, that is stupid. That's a stupid thing to say, but that's what he wants you to do. So pick it up again.
People have asked themselves since the beginning of time, what is time? What is this strange thing that constantly seems to be flowing, yet is always in the present and will soon become
Present,
past?
not present.
And what Einstein said was that time is what a clock measures. Now this may seem like a silly answer, but by taking...
It may seem like a silly answer, and it is a silly answer, but of course this person, he's going to defend talking about it in that silly way, so carrying on.
What is time? What is this strange thing that constantly seems to be flowing, yet is always in the present and will soon become the past? And what Einstein said was that time is what a clock measures. Now this may seem like a silly answer, but by taking that idea seriously, Einstein was able to come to remarkable conclusions about the nature of time. Let's think about a clock.
So, taking the idea seriously, you come to some remarkable ideas, but really, you say it's a silly idea. Why are you going to start from some silly idea like that? It's just silly. I'm going to get rid of these subtitles, they're just getting in the way a bit. There you go. So he's going to get onto the light clock now. So get onto the light clock, and we're starting from Einstein's silly idea about time.
It was that time is what a clock measures. Now this may seem like a silly answer, but by taking that idea seriously, Einstein was able to come to remarkable conclusions about the nature of time. Let's think about a clock in the way that Einstein thought about it. Now remember what Steve Chu said yesterday, that Einstein took seriously the idea of Maxwell, that the speed of light was the same regardless of the frequency, and extended.
So, quoting Maxwell to try to back up Einstein. So, go to that. I've dealt with it before in another talk or video. In this one, I explain Maxwell did not predict special relativity. It's another one of these claims that people who believe in Einstein's relativity like to make. They like to point to Maxwell's theory and claim it comes from there, and it doesn't. What you really got is just a strange interpretation of Maxwell's theory by Einstein. It does not come from Maxwell's theory unless you're prepared to make a strange interpretation. And we've already got, if we get back to this talk, we've already got with this talk that William is emitting, the person giving the talk, William, is emitting that it's from a silly idea. It's from a silly idea about what Einstein's got about time, that time is what clocks measure. That means any clock going at any time, different rate, and you can just call that time, which is just nonsense really. It's silly and it's nonsense. But he's building upon that, and building upon taking that interpretation of what time is, he's then wanting to put on a strange, weird interpretation of Maxwell's theory. So special relativity doesn't come from Maxwell's theory, it's just Einstein placing a strange interpretation upon it.
In the way that Einstein thought about it. Now remember what Steve Chu said yesterday, that Einstein took seriously the idea of Maxwell, that the speed of light was the same regardless of the frequency, and extended that to say that the speed of light was the same regardless of the observer. So imagine you...
So he extended it even. He sort of, so say, took it from Maxwell, took a strange interpretation from Maxwell, and so say extended it further. It's sort of, it doesn't make any sense. And if I've gone to one of my other video talks, which I've made, here we go. I think it's on the next one. That one. But when we look at what Einstein's doing, and it's pointed out by G. Bernstein Brown in his paper, whatever Einstein's doing, it's just strange. It's a sort of cuckoo process from Einstein. So Einstein's got this cuckoo process where he's going to do these weird things which don't make any sense. So we can go back to it and make it bigger. Oh, here we go. We're on to the light clock now.
Got a clock. That ticks every time light bounces between two mirrors. Now, if you take seriously the idea that light travels at the same velocity for all...
He said if we're going to come back to that. We're going to go with it for the moment, but he said if. We're going to go through his whole thing and come back to this if.
Observers, then if I am moving with this clock that has light bouncing between the two mirrors, I see it ticking away just as I would if I were at rest compared to you, because moving at a uniform velocity changes nothing for me. But what does it look like for you? For you, it looks like the light is following this zigzag path, and because light always moves at the same velocity, it must take longer for my clock to tick as seen from your point of view. That means that time is running slower because, after all, time is what a clock measures. And using this idea, Einstein was able to come up with his idea of time dilation. Now, if time is what a clock measures, let's go back to the PowerPoint, please. Let's stay with the PowerPoint until I tell you not to. Okay, so if time is what a clock measures, then time itself slows down with motion, as do all clocks. This is what we call time dilation. Now, you may ask yourself, well, what kind of clocks do we have? Well, we have a tremendous variety of clocks, and we've had different...
So that was basically it. That's basically upon Einstein. He's now going to go off on clocks, which he's involved in, different types of clocks, and he's going to get on to demonstrating experiments using freezing things to very cold temperatures and talking about that. So that was the Einstein bit. So if I want to try and get back to this if question, if
people have asked themselves since the beginning of time, what is time? What is this strange thing that constantly seems to be flowing, yet is always in the present and will soon become the past? And what Einstein said was that time is what a clock measures.
That's weird. That is weird to say that. It goes against how time has been treated before Einstein.
Now, this may seem like a silly answer, but by taking that idea seriously...
So you're taking something silly, that's a silly answer, and you're taking it seriously. And you're going to build on that.
Einstein was able to come to remarkable conclusions about the nature of time. Let's think about a clock.
So, remarkable conclusions from a silly start.
In the way that Einstein thought about it. Now remember what Steve Chu said yesterday, that Einstein took seriously the idea of Maxwell, that the speed of light was the same regardless of the frequency, and extended that to say that the speed of light was the same regardless of the observer. So imagine
which is not quite correct, as I pointed out earlier.
that you've got a clock that ticks every time light bounces between two mirrors. Now, if you take seriously the idea that light travels at the...
If you take seriously that idea about light, now that's the relevant thing. Now, he said if. The relevant word is if. So, I don't think you should take that idea seriously. So when he said if you take the idea seriously, did he really mean that, or he says you have to take that idea seriously? If you've got the option of not taking the idea seriously, then you don't have to go the way that Einstein went. So if I go back to so if I go on to this video, I showed that variable light speed is hidden in relativity by a bit of math manipulation, and what we end up with from that video, we get this. This is the sort of math manipulation they have. So you've got that distance along there as CT, that distance along there is VT, and that distance along there is CT0. And that CT0 is going to be different to the T's along here, which doesn't really make sense. That time and that time the same, but that time is different to those times. And you end up with that equation. If you and what you can do is you can form that triangle if you wanted to. You can remove T0 by saying T0 is equal to that, and then you can just write the triangle with just T's. So you've got CT along there, VT along there, and that speed times T along that direction. So if you then divide everything by T along that triangle, you have a speed along there is C, speed along there is V, speed along there of that being that. So if we go back to that, based upon that, time along there, time along there, time along there is all going to be the same. And that is instead of the nonsense they decided to go of having that T0 to be different to that T. It doesn't make sense to say that. It doesn't. To have that is Newtonian physics. That makes sense. Where you've got the same time along here and along here and along here. Newtonian physics. Why would you want time to be different along this direction? So we go back to it. So his relevant word he used was if. If you wanted to go by going by Einstein's idea, then you're leaving Newtonian physics. So why? Why are you going to choose that option? Why not just stay with Newtonian physics? Because it makes sense from Newtonian physics. I'll go back to it.
Come to remarkable conclusions about the nature of time. Let's think about a clock in the way that Einstein thought about it. Now remember what Steve Chu said yesterday, that Einstein took seriously the idea of Maxwell, that the speed of light was the same regardless of the frequency, and extended that to say that the speed of light was the same regardless of the observer. So imagine that you've got a clock that ticks every time light bounces between two mirrors. Now, if you take...
So the subtitles have been a bit messed up, but roughly as it got here. Now if you take seriously the idea that light is going to be behaving in the way that Einstein says then you ended up with all this nonsense about time dilation. And the word here is if. Have you a choice? Have you a choice going with Einstein or going with Newton? If you've got a choice, why are you leaving the way Newton would deal with this and going with the way that Einstein's dealing with it? And if you look into all these texts on Einstein, about all these people saying how clever Einstein is, they don't give you a reason for why are you going to deal with it a different way to what way Newton would deal with it. It's just a non sequitur. It just does not follow. Does not follow why you're going to make that change. You've got this light bouncing up and down here, and from an observer watching this moving, you've got light going at an angle. But why? Why are you still not? Why are you going to give up treating the way Newton would treat with it? So, did he, when he said if you take the idea seriously, did he really mean if? Did he really mean that? If he's saying if you take the idea seriously, why are you taking the idea seriously? Why not stay with Newton? So it may be he made a mistake by using the word if. Or maybe he is trying to point out you don't have to do things the way that Einstein does things. And that's the whole point of it. If you don't have to do things the way Einstein's dealing with it, just go back to Newton. So what does he mean? Is he aware that you don't have to do things Einstein's way? And hence why he used the word if. It's just a bit of maths manipulation to give you time dilation. Whereas if you staying with Newton, you would have no time dilation, and you would have variable light speed. So why? Why do they do that? We look to Newton, we look to Einstein to see what he's doing, and it's just cuckoo. Doesn't make any sense whatsoever what either he's doing. So that's my little talk here finished. Thank you.